I've been asked for some help with balancing equations, and I thought I'd put a video together to see if I could do that via video. Two things you need to be aware of when balancing chemical equations is, first of all, the law of conservation of atoms, or law of conservation of mass, and that is you can't create or destroy atoms in a chemical reaction, and therefore the atoms in your reactants must be exactly the same as the atoms in your products. The atoms can rearrange, but you can't create or destroy atoms. And the second concept is something about chemical formulae. Now, this is what we've been practicing for the last week or so in chemistry, the fact that we have different chemicals and they've got definite formulae. For example, sodium chloride is NaCl. It's not Na2Cl or NaCl2. Every chemical has a set formula. So each compound has a fixed chemical formula, and this formula can't be changed. But combining these two rules together means that there's certain ways of balancing chemical equations. And I thought I'd start off with a simple equation. It's the first one on your practice sheet. It's hydrogen gas plus oxygen gas turns into water. Now, just be aware that most of the elemental gases, apart from the noble gases, exist as diatomic molecules. They exist as two atoms joined together. So rather than just having a H, it comes in H2. The two atoms are joined together. So you've got H2 plus O2 goes to H2O. Now, right now, this is what we call a non-balanced equation. Because if we look here, we've got two hydrogens in our reactants. And yes, we've got two hydrogens in our products, the water. So that's balanced. The hydrogen is balanced. But look at the oxygen. We're starting off with two oxygen atoms in the reactants. We've only got one oxygen atom in the products, and therefore what's happened, if this was the chemical reaction, an oxygen atom has just disappeared into nothingness, and that can't happen. You can't destroy oxygen atoms. So if there's two oxygen atoms in the reactants, there must be two oxygen atoms in the products. But that oxygen on its own is not water. I mean, this reaction has told us we're making water. So for there to be another oxygen in the products, there must be two other hydrogens in the products as well. So if we have a whole oxygen molecule reacting, that is, those two atoms there have to make two water molecules. But for that to be true, we just balance water now. So we just balance the oxygen now. Now we've got two oxygens on this side. We've got two oxygens on this side. But now we've unbalanced the hydrogens again. Now we've got four hydrogen atoms in the products, only two in the reactants. So the only way to resolve that is if we must have had two hydrogen atoms in the first place. So, oops, try that again. There must have been two hydrogen molecules. If I can move that, hopefully I can. Yeah, there must have been two hydrogen molecules in the reactants. So now what we've got is two hydrogen molecules react with one oxygen molecule to make two water molecules. And the way we represent that in the chemical equation is we put numbers out the front. We'd say something like 2H2 plus 1O2, like in chemistry before we didn't write the ones, going into 2H2O. And that's the balanced chemical equation. If we look at that, 2H2, that means two lots of H2 or four hydrogens. Over here we've got 2H2O, that means two lots of H2O. In that 2H2O we've got 1, 2, 3, 4 hydrogens, so we've got equal numbers of hydrogens on both sides of the equation. O2 means two oxygens, and in those two waters we have two oxygens. So that's a balanced chemical equation. Two hydrogen molecules react with one oxygen molecule to produce two water molecules. If I just skip back there for a second, see if I can, without destroying this too much. What can I do here? Going right back to the beginning, it would have been much simpler, obviously, if we're trying to balance this, to think, okay, we've got two hydrogens there, got two hydrogens there, check, got two oxygens there, got two hydrogens there, only one oxygen here. How can we fix that problem? I know, let's just put a 2 there, H2O2. If we do that, there we go, done. We've balanced the equation. Two hydrogens, two oxygens, two hydrogens, two oxygens. The only problem is, even though we've balanced the equation, we haven't actually done what's asked. We haven't made water. We've made hydrogen peroxide instead. And therefore we can't just willy-nilly change the formula of a chemical. The chemical formula is fixed. It might make our lives easier to do it that way, but that's not the way chemistry works. We have to make sure we're not changing the actual chemical itself. So we go back now, this has to be 2H2, O2, and 2H2O. Let's look at the ammonia example down here. You've got hydrogen gas plus nitrogen gas turns into ammonia. And right now, the hydrogens aren't balanced. We've got two hydrogens and three hydrogens. So the hydrogens are definitely not balanced. Let's look at the nitrogens. Two nitrogens in the reactant side, only one nitrogen in the products. And I'm going to balance the nitrogens first, because to me that seems like it's going to be a simple job to do. Two nitrogens here. I have to have two nitrogens in the products. The only way to have two nitrogens in the products is if I actually have two ammonia molecules. So I'll put another ammonia in there now. Now I've got two nitrogens in the products. I've got 1, 2 nitrogen atoms here, and I've got 1, 2 nitrogen atoms there. Unfortunately, the hydrogen is not balanced. Right now here I've got two hydrogen atoms, and the products though I've got 1, 2, 3, 4, 5, 6. So I've got to somehow turn this one hydrogen molecule into 6 hydrogen atoms. And the only way of doing that is if I actually had more than one hydrogen molecule. So there's 2 hydrogens, there is 4 hydrogens, now there's 6 hydrogens. So I'll see if I can move them around a little bit so they're easy to see. Let's see if that's balanced now. Now I've got 6 hydrogens on the left hand side, I've got 1, 2, 3, 4, 5, 6 hydrogens on the right hand side, 2 nitrogens on the left, 2 nitrogens on the right. That's balanced. And that tells me that in order for this reaction to make sense, there must be 3 hydrogen molecules reacting with 1 nitrogen molecule to produce 2 ammonia molecules. Now, that's how you do it visually, and that hopefully that's made a bit more sense of how the chemical equations are balanced. But we don't want to always have to draw these diagrams. We just want to be able to simply balance them. And that's when you just start having to think in your head, trying to balance the atoms on both sides. And so here's another example. This is copper chloride plus sodium hydroxide goes to copper hydroxide plus sodium chloride. This is copper 2 chloride for the record, and that's copper 2 hydroxide, and also a valency of 2. We've got to go ahead and balance this equation, but it can be daunting at first to think about which atoms to balance first. And there's no strict rule for this, but in my experience I've found this to be the best method to follow. I find that if you balance the metals first, then the polyatomic ions, then the nonmetals, and particularly the nonmetals, the halogens first, then carbon, hydrogen, oxygen. If you do things in that order, it seems to work out. So let's try and follow my advice for that one. So first of all, it says balance the metals. I'm going to look at copper first. In this side of the equation, the left-hand side of the equation, I've got 1 copper, CuCl2. On the right-hand side, I've got 1 copper. So right now, copper seems balanced. I've got 1 copper on both sides. Look at sodium, the next metal. Sodium, I've got 1 sodium on the left-hand side, 1 sodium on the right-hand side. Sodium seems to be balanced. So let's look at the other things. Next thing on this is polyatomic ions. In this case, it's hydroxide. Left-hand side, I've got 1 hydroxide. Right-hand side, I've got 2 hydroxides. Now, it'll make my life a whole lot easier if I could just put this in here, change sodium hydroxide's formula to NaOH2, because now the hydroxides will be balanced. But as we know, we can't just change the formula of sodium hydroxide. The laws of physics and chemistry say the sodium hydroxide formula is NaOH, so we can't do that. But I still need to get somehow 2 hydroxides on the left-hand side of the equation. The only way to do that was to actually have 2 molecules of sodium hydroxide. So now I've got 2 hydroxides on the left, and I've got 2 hydroxides on the right. Downside that is though, now I've got 2 sodium atoms on the left, I've only got 1 on the right. Well, that's easy to solve. If I put 2 out the front now, that means I've got 2 sodium on the left, and now I've still got 2 on the right. So far my coppers are balanced, 1 and 1, my sodiums are balanced, 2 and 2, my hydroxides are balanced, 2 and 2. The last thing is to balance is the chlorines. I've got 2 chlorines on the left, I've got 2 units of NaCl, which means I've got 2 chlorines on the right, so everything's balanced. So that equation is balanced just by putting a 2 in front of sodium hydroxide and a 2 in front of the sodium chloride. The next one down is a bit more challenging. I recommend you pause the video and have a go at it yourself, then you can press play and see how you went. Alright, barium nitrate reacting with aluminium sulfate to produce barium sulfate and aluminium nitrate. First thing as always is to balance my metals. So barium's got 1 atom on the left and 1 on the right, so my bariums are balanced. Next look at aluminium. I've got 2 aluminiums in this aluminium sulfate. I've only got 1 aluminium and aluminium nitrate. That means I need to get 2 aluminiums on the right hand side to balance the 2 on the left hand side. I can't change the formula of aluminium nitrate, but I can have 2 aluminium nitrates, and therefore I've got my 2 aluminium atoms on the right hand side. The next thing to do is balance my polyatomic ions. So I've got 2 nitrates on the left hand side because BaNO3 2. But look at this right hand side. Aluminium nitrate has 3 nitrates, but now I've got 2 aluminium nitrates. So 2 lots of aluminium nitrate, each with 3 nitrates. That means I've got 6 nitrates in total, which means I've got to come over here and make this be 6 nitrates on this side. So I've got to put up 3 at the front, because 3 lots of barium nitrate, each with 2 nitrates, gives me my 6 nitrates. But just like before, now I've got 3 barium atoms. I've got to make sure I've got 3 barium atoms on this side as well. So my bariums, 3 and 3, check. Aluminiums, 2 and 2, check. Nitrates, 3 times 2 makes 6, and 2 times 3 makes 6. Nitrates balanced as well. The last thing I check is sulfate. In aluminium sulfate, I've got 3 sulfates. In barium sulfate, I've got 1 sulfate, but I've got 3 barium sulfates in total. So 3 sulfates, 3 sulfates. That equation is balanced. The last level of complexity for these sort of balancing equations problems is if you have to actually write the chemical formulas and then balance. So the first step is to go ahead and actually write all the formulae of each species using the cross method, making sure you get it right. So as a first step, I'm going to recommend you pause the video, use your cross method skills to write the correct chemical formulae of each of these species underneath the name, then we can go and try and balance that. So pause it now and get the chemical formulae right. Okay, let's see how we went with balancing, well, not balancing that equation, but writing the chemical formulae. First of all, iron 3 nitrate. Iron's got a valence of 3, nitrate's got a valence of 1, so it's FeNO3 in brackets 3. Magnesium hydroxide. Magnesium's got a valence of 2, hydroxide's got a valence of 1, so it's MgOH2. Turning into iron 3 hydroxide. Once again, iron's got a valence of 3, hydroxide's got a valence of 1, so it's FeOH3. And magnesium nitrate. Magnesium's got a valence of 2 and nitrate 1, so it's MgNO3 2. So now we're going to go ahead and try and balance this chemical equation. The first thing, let's balance our ions. One ion on the left, one ion on the right. Ions appear to be balanced so far. Magnesium's one on the left, one on the right. Magnesium's balanced. Let's try and balance our nitrates now. Left hand side we've got 3, right hand side we've got 2. That's going to be tricky to balance because 3 and 2 don't really match up. So what we might have to do, if you can't actually make those two numbers work, sometimes it's best to double the biggest one. So now I'll put a 2 at the front here. So let's just say now I've got 1, 2, 3, 4, I've got 6 nitrates on the left, I need 6 nitrates on the right. If I put a 3 at the front of here, I've got 6 nitrates on the left and 6 on the right, so the nitrates are balanced. Let's look at the hydroxides now. Hydroxide's got 2 on the left and 3 on the right. Similar thing again, if I put 3 at the front here and a 2 at the front here, I've got 6 hydroxides on the left and 6 on the right. We've got to go back now and check our metals. 2 ions, check. 3 magnesiums, check. That equation is balanced. Now you should be able to go ahead and do some more chemical balancing.